And I'll show you something about my project. Literature review. About my literature review, I choose two scientists or the research before me. The first one, Morkik, he did biomechanical modeling of human walking, and he did imitate between the human wake and the robot wakes. And the second one, they generalize the standard food trajectory for an aquatic walk vehicle. And this paper is converted in the World War II. He did something like that. Yeah. And the first, my robot has two sections. The first one, 4 bar mechanisms, and the second one, pantograph mechanisms. The first one, the 4 bar mechanisms, the first part, I'll show you just, yeah. From here, in this part, I choose 4 bar mechanisms, and the second part, I choose this one for the pantograph mechanisms. So, I am going to test this part and this part, exactly at this point P and point A, because I need this trajectory exactly, what I am going to explain. The trajectory shape, it looks like this one, the first one, and the second one, it will come like in the inverse of the first one. Please next slide. Yeah, please let me show you the simulation about my trajectory. No, just like, that's great. Yeah, it's so clear here what I am going to design. Please next slide. Yes, here exactly I have used the ProE, Professional Engineering software, to modeling all my projects. So this is the first thing part, what I choose from the aluminum, and I'll show you what is the type of materials I already choose here. Please, okay, the density, the 2740, the modeling, Young's modeling, and the Gaussian ratio, and all my material, it comes like this one. It means all my material, they are same. This is the one. Yeah, the part number 2, dimensions 100, please, like 100, same width. And the second one, third one, sorry, length 11, and the width is 2. Please come to the assembly part. This part number 5 and number 6, 7, 8. Yeah. Here, this is all my parts assembly. So the first part and the second part, the long one, they will be fixed in the operating system. And this part, and this part, and that part, and this point, they will be 4 bar mechanisms. And from here up to this part, pantograph mechanisms, what I explained before. Yeah, this is, I finished my modeling, so I need to do some analysis. So I choose the Adam software to make analysis to my project. Please, yeah. I have taken just 5 velocities. The first one I start from 22 RPM, and the second one I made double for my project. Yeah, and the third one I did for 88, and the last one 110. So now, here I did translation displacement in magnitude component at 22 RPM. Next step. Yeah, here I translation acceleration in magnitude component, and this exactly in the part number 5. It means in the point B. Yeah, here I did some motion dynamic analysis in the same 22 RPM case. So here I need the torque. I need the torque. So I did that one. Okay, so I'll show you simulation what I did in my experience. This is yeah, so here all my design that comes by very well, I can operate in that much of level. Okay, please. Yeah, power constants. Okay, dynamic analysis. Just wait. Thank you, Sam. Yes, dynamic analysis of the link motion and this robot link mechanisms. Now I change the level for my speed. So I choose here 110 RPM. And in this part exactly, I show you how it's my modeling, it comes to fail. Translation acceleration, the magnitude component, and in the part 9, in the mic number 53, okay? translation displacement is yeah, here's the translation magnitude also. Motion. Yes. Because of I need to get the stasis values, so I can't do my project and the rigid body. So I have to change from the rigidity to the flexibility. So I use the FEM, finite element method, to change my modeling from the fixed to the from the rigid to flexible. So I have used this one. And this one, yeah. And exactly part number 5, I go this type of stars as to be here. There are not that much values highest, so we can operate at that much of the stars. Yeah. So what I did in the part number 5, I choose the 22. I have got those stress what I showed you before. So this is my shape and this is my shape and configure part number 5. This is how. Yeah, and strain energy. Okay. And now I change for part number 5 this velocity acceleration from 22 RPM, and I took the highest value of velocity I can operate on. So I choose that part. I choose 110. Okay, and as so here, the values of stasis, it comes so high. So it's sure, I make sure about my, because I did myself. So now on this much of highest velocity, it will be fair, as I showed you now. Yes, exactly here at the part number, we will see the bending. So we can't operate in this much of speed in part number 5. Yes, yeah, as here, so here, angular deformation and translation deformation, it comes because of I increase the velocity value. Yeah, this is strain energy. Yes, and here I shifted from the part number 5 to part number 9. And as we see here, the values of the stars are 22 RPM. So here we can operate on my 22 without any fail. And there is some plots about my project strain energy. Yes, here I type this. As so here. When I change the velocity from the 22 up to 110 RPM, the strength comes so high because of the values of the flexibility for aluminum, and not that much to be operated with that much with these values of classes as so here. I show you the picture. Yes, so here we'll see the bending. It comes during the part number 9. This is something about the angular deformation and strain energy, and this is all my shape under 110 RPM. As Sockley here, yeah, as Sockley here, the bending in 2 parts. I show it. This is yes. Sockley here. I'll show you exactly where the deformation comes. Sockley here. The critical situation and the vibration on my parts. So I can't operate at that much level on my project. Yes, recommendations and conclusions. The modeling by using ROE and the model, yes, by ROE and Adams have been done. And the dynamic analysis of this is at 0.8 P, as I told you before. Already I have a stress analysis by Adams, and the speed value already increased from the double up to third values, up to fourth values, up to the highest value of what I got. Yes, and the areas for the research and improvement will be the physical modeling of the robotic mechanisms can be prepared, the first one. And the second one, if I increase the value on my speeds, maybe in future way, and maybe I'll change what I choose the part before. So I'll take the cross section of my numbers, can be test. And now here, thank you.
Yeah, Mr. Ali,
yes, sir.
Good presentation.
Thank you so much.
Did you find any difficulties while making this?
Yes, sir. I have found.
What are things you observed?
Thank you so much. What I'm saying, because of I work under my professor, I have to sometimes I have to ask him about his help. So he did many help for me. So in my alone,
Tell me some of them. Many means that is a That's the infinity answer.
Please don't put me in a critical situation.
No.
Me and my
What are
life.
the exact problem did you face? Tell me. Where you stuck up?
What is okay?
You are doing this.
Yeah, because of I need to model it, so I need softwares. So what I am going to choose is so difficult to my suitable project. So I have to ask my professor, and he will direct me which type of modeling I am going and which suitable software I am going to choose. And this part, and
No, everything, which sum, everything you are adding it. I want exactly answer.
Exactly answer.
So everything can say that
You want
exactly this,
to, you want
that.
to put me in a critical situation. I am sure about it.
No, because you are
Yes.
from Iraq.
Yes, sir.
You are happy because you are coming
Thank you
to
so
studying
much.
in India.
Yeah. Also,
And
me,
you are
I'm
utilizing all the facilities in the JNTU Hyderabad. And you learn so many softwares, ProE and
exactly. Adams.
modeling analysis, ADAMS and
Yeah.
other
Matter
ANSYS,
yeah.
right?
No, not ANSYS. I haven't used ANSYS. I used the Adams software instead of the ANSYS. Yeah.
Okay, where this application where you are going to use this robot?
In many applications.
Tell me some applications.
Yes, I will tell you. I'm going to tell you. The first one, we can, if you want to visit another planet, okay, you will choose this one. And the second one, if you want to for space. But if you are going to use our life, is just go to the any factory for welding or any factory for modeling cars. We have to use this type of robotics thing.
The space, I will use this.
Yes, sir.
How?
Okay. By simulated this one.
No, you simulated, we manufactured the robot.
Yeah.
Then how will you use that?
How we are going to use?
How will you use the robot?
How I am
You
going
told
to use.
that application we can use in space also.
Exactly, sir.
The space, how we are going to use the robot?
Okay. Because of I told you that. Now I have to explain something about the space because as so clear here in our modern life, we have to use something that not that much has weight and sometimes it has some type of the strength value. So I choose this one to be suitable to shift it from here to the space, but not yet.
In
Maybe
the
after
space you are
future.
sending the robot?
Sorry?
You are sending the robot to the space?
Yes, I am going, but not me. But my
No,
ideas.
you means you are, okay, robot is available.
Yeah.
So what the robot is going to do in a space? How
Exactly.
it is doing, what is the application of it?
What is the application of it? Because of, as I told you, sir,
In space we are sending the human being itself.
So this is so
Astronauts
dangerous.
are
sir.
going, right?
No, this is so dangerous nowadays.
Why?
Because, why? Because this is life for the human. How can we spend life
No,
of
no,
human
people are going to travel like a tourist.
for the tourists? I am not going to talk about the tourists. I am
No, no,
going
no.
to talk about the way.
The tourists itself they are going, what the robot will do in the space.
I don't know, sir.
On new planets, you can say like
Yeah,
that.
maybe.
Yeah, on new
Okay, new planet, what you will observe in that?
Yes, exactly.
No, no, what the robot will observe in the new planet?
A new planet?
Uh-huh.
I'm not sure. Sir.
Okay, we know that Mars,
Yes, exactly.
Venus, so many planets are there, right?
Yeah.
There is a 9 planets mainly, we know that.
Mm-hmm.
So you are sending to some planet or a moon or
Maybe
a Mars.
Mars.
So what the things will observe over there? The
Mars
robot.
to discover the surface of that planet.
What discoveries? What are the things?
Because of, okay, now you came here from that place in JNTU. You have no idea about JNTU. So if you come here,
Why not? You can type it, internet, everything is available. What is available in Iraq?
I am
You know
saying,
that.
okay,
What is
sir.
available in Hyderabad? You can learn.
but if suppose Hyderabad not discovered yet, so you will be a first person who visit Hyderabad.
Ali, at this moment, in this century, we
Yes,
know
sir.
everything. Then the application of the robot.
Sir, maybe you know everything.
You know
something
then,
you know
I know.
about.
He may be knowing.
No,
What you have to tell.
You tell me that what the robot will do in another planet. What are the things it will
What will
observe?
be the surface of it? Just imagine
My
and
robot, maybe he will go also for road tourist. I suggest that one, just go for tourist and discover at the same time.
So what will do the tourist? He will see them come back. I will get the information to the robot.
I'll take that information from his mind.
How?
I have computers.
From mind, how will you get it?
I will, see, this is not my specialty, sir, so sorry.
Generally,
My-
it is going to the planet. Here you can observe that what is the atmospheric conditions.
Okay.
Oxygen is there or not? water is there or not. Any minerals are available on that planet.
Exactly.
Surface also.
Exactly. Yeah.
Terrain also it is not even uneven.
Yeah, that's what I am
And,
saying.
Now in Iraq, petrol is available. And the Mars also petrol and some other oil is
Yes,
available.
I agree with you.
Is available or not? Give the feedback. It is available or not? Go there.
Yeah.
Petrol is available. It gives yes. Not available. Not fine.
Yeah, like it has an oil, and nowadays this is our problem. Okay.
So tomorrow I can send the rover to Iraq.
Yeah, it's
There,
my pleasure, sir.
there I can get the another linking to petrol to the India without your permission.
Exactly. Sir. I welcome you and your problem.
Okay, Ali. Any questions from audience? Anyone? Please can ask some questions. Okay. Thank you.
Thank you so much, sir.
Good luck. So the next one.
Mr. Imam.
هذه المناقشة يوم 28/8/2014 للأخ علي كامل. مناقشة رسالة الماجستير في هندسة الميكانيك.